we're thinking about base 20. Okay, and I notice my 360 is too large. So I'm going to have to express this in terms of the number of 20s and the number of 1s. So what I want to do is divide 20 into 296. 20 will go once. 20 will go into 96 4 times. And we have 16 ones left over. So I need to express 14 20s and then the 16 ones. Okay. Now what they're going to do is they're going to stack these vertically, whereas we were doing the Babylonian system horizontally. This one we're doing vertically. So I want 14 20s. So that's expressed by 2 5s and 4 1s. That's 14 20s over 16. So we need 3 lines for 15 and a 1. So we have 16 ones and we have 14 20s. Let me write it that way, 20s. So that would be the way they would write that number. Okay, do you think we're ready for one that's a fairly large one, 8,471? Okay. All right, so this time we can go as far as the 7,200. So we want to take 7,200 into 8471. It goes once. Okay, so we're going to have one 7,200. Now we want to look at how many 20s we're going to have, or 360s I should say. We have 1271. We need to know how many 360s we have in that. All right, I'll resort to the calculator again. 1271 divided by 360 gives us 3. And 3 times 360 is 1,080. Subtract 17. Okay, so I have 191. Now I'm going to do 20s. So I've done 7,200s, 360s. Now I'm doing 20s. And let's see, looks like 9. And then we're left with 11 ones. Okay, so we need 1 7,200. We need 3 3,600s. And we need 9, so nine 20s. And then we need 11 ones. So I need 2 of these and a dot. So here we have the 7,200s, the 360s, the 20s, and the 1s. Okay, we have one last system that's not positional. It's what they call a ciphered system. It's very different from the other systems that we've looked at, the simple grouping, the multiplicative grouping, and the positional. It is base 10 with 27 distinct symbols. So as you can imagine, while the numbers are very easy to write once you know the symbols, having to memorize 27 distinct symbols would be difficult. Now, my table of values here is missing a few because I couldn't find them on the computer keyboard. So I'm going to add in the symbol for 10. Looks like an I without a dot over it, slightly, a script I. The number 90, okay, Looks like a lollipop to me. And the number for I think 900 is the other one I had trouble getting. Okay, so those are the symbols that are missing. You'll need to add those into your sheet. Now, it turns out that the numbers are very easy to write. Basically, you just write the two symbols. So 47, we just look up here, and a 40 is a mu. And then we go up here, and 7 is, I don't know what that's called. Looks like a squiggly. Okay, so that's all we have to do. So in that respect, it's fairly easy to write. Okay, 825 would be 800. All right, 20 is the K, kappa. Okay, and a 5 is an epsilon, I believe that is a capital. Maybe. Okay, now when you get, you'll notice that the table does not go beyond 900. What do you do when you're writing 1,000? Well, what you do is you make use of the figure for the 9, which in this case, okay, is our theta symbol. And you place a small stroke next to the theta to indicate it's 9,000. Okay, and then what we do is the 600. Got to get the symbol for 600. 10 is, oh yeah, the curvy one without the dot on it. And then our 2 is the beta. I can remember that one. So that would be 9,612. Now, if you go into the 10,000 position, what you do is you write an M with the multiplier above it. So like if you were trying to write 50,000, you would look at the symbol for 5, write it very small over an M. Okay, so that is our Greek ionic system. Greek ionic system, I believe. Yeah. Okay, and I don't expect you to memorize these. Again, you'll be using your notes. Main thing I want you to understand is how the system is put together. You know, when it's positional, when it's simple grouping, and that kind of thing, because it will help us to understand our own system and appreciate it more. So at this point, you should be ready to go do some practice problems. Watch the sample problem recording that I'm going to do right here.